Solve the following inequalities, then graph the solutions on a number line. If we take a look at problems E and F, we see the absolute value of x plus 7 is less than or equal to 3, and over here, the absolute value of x plus 7 is greater than 3. Now, before we try to solve these two absolute value inequalities, let's just recall how we might solve something a little more basic, such as the absolute value of x is less than or equal to 3, and the absolute value of x is greater than 3. Now, if you want to solve the absolute value of x is less than or equal to 3, that means we're looking for all the numbers a distance less than or equal to 3 on the number line. Well, those numbers would be between -3 and 3. Again, because these are the numbers that are a distance less than or equal to 3 from 0 on the number line. In order to express these numbers, we would have to use a compound inequality. We'd have to say that x is less than or equal to 3 and x is greater than or equal to -3. Our values of x have to satisfy both of these inequalities, so we have to put the word "and" to connect these two inequalities. Now, if the absolute value of x is greater than 3, that means we want the numbers that are a distance more than 3 from 0 on the number line, which would be the numbers to the right of 3 and to the left of -3. And if we want to express these two regions in the number line, we would have to use a compound inequality, and we would have to say that x is greater than 3 or x is less than -3. We can't combine these with the word "or" because we can't combine these two inequalities with the word "and" because a value can't be both greater than 3 and less than -3 at the same time. The x's can only be one or the other. So if we summarize these two basic absolute value inequalities, we see that if we have the absolute value of x is less than or equal to a number, we have to break this up into two inequalities with the word "and." You'll notice that the first of these inequalities has the inequality going in the same direction as the absolute value inequality, but the second inequality has the direction going in the opposite direction as this absolute value inequality. It's a very similar situation here when we have the absolute value of x is greater than a number. We have these two inequalities, but we have to connect them with the word "or." And again, for the second inequality with the -3, we have to switch the direction of the inequality. So now let's take a look at problems E and F. So we have the absolute value of x plus 7 is less than or equal to 3, which means that this quantity, x plus 7, has to be less than or equal to 3, and that quantity, x plus 7, has to be greater than or equal to -3. Now that we have these two inequalities, we can solve each of them one at a time, each by subtracting 7 from both sides. So we would get here x is less than or equal to -4, and here x is greater than or equal to -10. So this compound inequality is our solution to this absolute value inequality. And the graph of our solutions would look something like this. Since x has to be less than or equal to -4 and greater than or equal to -10, that means our x's, our values, have to be between these two numbers. Now, if you have the absolute value of a quantity is greater than a number, that means this quantity inside of the absolute value has to be greater than 3 or less than -3. So again, we'll solve these two inequalities one at a time. So here, if we subtract 7 from both sides, we get x is greater than -4, or x is less than negative 10. And if we graph our solutions, if x is greater than negative 4, that means we need to shade the numbers to the right of negative 4. And if x is less than negative 10, then we shade the numbers to the left of negative 10. So if you look at problems E and F, you'll see that they're very similar. The only difference is that we're connecting them with the AND when we have the less than, and we connect the two inequalities here with OR if we have this greater than. Now, take a few moments, pause the video, and try problems G and H. Now, problem G is similar to the two problems we tried a moment ago, but this negative 2 makes it slightly more complicated. So, in order to get rid of this negative 2, I will divide both sides of the inequality by negative 2. Recall that when you divide both sides of an inequality by a negative, you must switch the direction of the inequality. So if I divide the left side by negative 2, I get rid of it. And if I divide the right side by negative 2, I get negative 4. Now, something a little curious happens in problem G. If you think about this negative here, it says that the absolute value of a quantity is less than a negative. But the absolute value is a distance, and a distance can't be less than a negative because a distance can't be negative. So in fact, this has no solution. That's something to keep your eye out for. If you have the absolute value of a quantity is less than a negative, that can't happen since a distance has to be positive, or I suppose a distance could be 0, but a distance can't be negative. So our absolute value can't be less than a negative. Now, let's take a look at H. Again, let's just simply start by trying to isolate the absolute value. So I'll get rid of this minus 2 by adding 2 to both sides. So 4 plus 2 is 6. Now, to get rid of this negative 3 here on the bottom, I'm going to multiply both sides by a negative, and when we multiply both sides of an inequality by a negative, we have to switch the direction. So this would give us the absolute value of x plus 8 on the left, and on the right we would have 6 times negative 3, which is negative 18. Now, this is slightly different than what we got in problem G. Here we have the absolute value of a quantity is greater than a negative number. And since a distance has to be positive, that means the absolute value will always be greater than a negative, regardless of what x is. So in fact here, our solutions would be all real numbers. You can pick whatever x you want. If you put it inside of this absolute value, when you take the absolute value, it has to be at least 0 or positive, which means it must be greater than or equal to, just greater than negative 18. So if we were to graph our solutions in part H, well, we would have to graph the entire number line, whereas in G, we would not graph anything on the number line.